Two more cool and unique fans on this video today. We have the Cooler Master Fan SF120M and the Antec Storm120. Let's get right into the graphs and the data to do the fan analysis, and then we'll do our open box, see the time stamps to jump to whatever sections interest you. Alright, first some basic spec information. On the left side we have the Storm120. On the right side we have the Storm120 uses an FDB bearing, while the SF120M uses a dual ball bearing. Both are 12 volt. The RPM range for the Storm is 600 to 2000. The Storm has a variety of speed settings, but the main one to keep note of is the high speed, and it goes from 650 to 2000, so a very similar speed range. And of course you can set it to low, but personally I don't see a reason to do that. Airflow in CFM for the Storm is 66.56, and for the SF120M it's 62, medium 46, and low 35. Static pressure for the Storm is 2.7 millimeters of H2O. For the Master Fan, it's 2.4, 1.6, 0.93. Noise levels listed there, 34.9, 22, 20. So the Cooler Master Fan is substantially quieter by their ratings. Also, mean time between failure, the MTBF, the Storm is rated to last a lot less time. The Cooler Master is listed at lasting 280,000 hours. So it's a very long lifespan by their ratings. And I just wanted to note, because I did review the Storm T3, and so you're going to see some graphs with it in there. So they've got the regular Storm Edition, which tops out at 2,000 RPM and is a regular thickness, and then they've got the Storm T3, which is a 30 millimeter thick fan, and its performance ratings, just as sort of a comparison point. I wanted to show this off because I thought it was interesting. Now on to the actual graphs and the data. The first graph here is my case simulation test. So first and foremost, what is this test generating? Well, there are two main points to look at it. First is I took measurements at a variety of different distances from the fan. So 6 inches, 9 inches, 11 inches, and 14.5 inches. Those distances are representative of different size cases. So at 6 inches, it's representative of a small form factor, fairly small, tight case. At 9 inches, it's representative of a small case, but more or less a standard type format. At 11 inches, we're looking at a medium-sized case. That would be considered like a Corsair 550D or the mid-sized towers from Fractal Design, or other manufacturers as well. It's just first brand to pop to my mind, because the last one at 14.5 inches is representative of large cases like the Corsair, or not Corsair, Fractal Design Torrent, which is what that specific measurement comes off of. The second key takeaway from this information gathering is how much does the fan focus its air or lack thereof. So does the fan essentially create a nice column of air being pushed straight to the back of the case, so it has very little airspeed drop as it goes from 6 inches to 14.5? Or does it have a very fast drop, indicating that the air is not focused at all and is spreading out throughout the entire case? Personally, I like the focused airflow because I want it to push through, but having some airflow is better than no airflow, and that's kind of period. So depending on what size computer case you're looking at, really depends heavily, or allows you to focus in on which data point you would care about most. And when you're looking at these lines, you want them to be as linear as possible. A very steep drop-off indicates basically that it all of a sudden just drops in performance. It basically just spreads the air out so much, and it's not worth really looking at that point. So let's focus in on what we're taking a look at now. So we've got the Master Fan SF120M, and it's taken at a number of data points, so 20, 40, 60, 80, and 100% PWM fan signaling. And we can see that it creates a pretty linear graph but we got nothing to compare against, so this is just comparing against itself, and overall looks pretty good. The fact that it even has airspeed registering at 14.5 inches at the lowest is a truly remarkable feat. It means it does have a pretty good focused airflow. As for the Storm120, it is a terrible result. It's just not worth looking at as a case fan. Particularly looking at its lower RPM, so 700 and 1800, it just drops to 0, and it stayed there. If you're taking a look at it in a small form factor, it may be worth considering, but anything larger than that, I would just ignore this fan. But keeping along the same trend of these type of graphs, we're going to be taking a look at my noise normalized results versus my control fan. My control fan is based off of the Noctua NF A12X25 with a little bit of A14 from Noctua mixed into it because I wanted better air velocities, basically at the 14.5 inch mark that you get with a 140 millimeter fan. So I noise normalized the results and averaged them together in about a 3/4 A12X25 to 1/4 A14 in that ratio from the results, if you were to look at my previous videos where I went through each of those fans. Anyways, so our takeaway here is any fan that outperforms the control should be considered a good fan. Any fan that matches it should be, or any fan that matches it should be considered a good fan. Any fan that exceeds its performance should be considered good to excellent, depending on how much higher it is. And fans that are below it should be considered not particularly good, but it all depends on how close in performance it is. So looking closely at the data, we can see that the master fan is a very good performer. It truly outperforms my control fan in this noise normalized result. The Storm, on the other hand, is a very bad performer, and again, I just wouldn't recommend it for anything larger than a small form factor case. Moving things up to that 100% PWM fan signal, there's my control fan, and the master fan has lost a lot of ground. It's just not as high-end performance difference between my control and the master fan. But if you look over here, we have the RPM of spinning as well as the noise level. The Storm, on the other hand, did sort of move up. In my opinion, it's doing a little bit better here, but if you're running your case fans at 100% PWM, something has gone wrong in your case, and it's terribly overheating. So kind of ignore this, I guess, but it's doing okay. It's not good though. Next up in our graphs is performance through my CPU air cooler, the Noctua NHU12A, I believe, if I remember all the names correctly. And the first graph on the left side is RPM versus airspeed. So this is a pure blade efficiency type graph. So it's how good is this fan with this blade design at moving air. On the right side is noise versus airspeed, and that is a noise efficiency graph. So it's how much air can this fan move at a per noise level. And when looking at these graphs, good fans are sitting over in the top left, bad fans are sitting in the bottom right. And let's take a look at it. Starting off on the left side with the RPM versus airspeed, my control fan is this darker blue line, which anything over it represents, again, a very good fan. Good to very good. And taking a look at the master fan, which is this light blue line, it is matching and doing a little bit better than my control fan. The Storm is actually doing very well. It loses a little bit of performance there at this 1700 mark, but then it kind of gains it back again, and it overall stays pretty level above my control. Comparing it against the Storm T3, they are very similar in their performance marks. Matter of fact, it even beats the Storm at moving air at lower RPMs, which is kind of surprising because the Storm T3 is a thicker fan, which means it should do better at moving air. But it doesn't really seem to be doing it, and at the maximum ARP or maximum speed, the reason it's even up there that high is because of its higher RPM. Jumping over to the right graph, we have the noise. So my control fan starts off here and then it's there, and the top performer here is the master fan. So the master fan right now is looking really good. But doing the noise, we can see that the Storm T3 looks to be doing slightly better than the regular Storm in this metric. It is a little bit more noise efficient, even though it's not performance-wise more efficient. So that is a very interesting result, and let's see if it holds true for the next graphs. The next graphs we're going to be taking a look at are my CFM tests, or cubic feet per minute. And this is where I basically blow air from the fan through a cylindrical tube. I know the inner diameter, and I know how fast the air is coming out the back because I have my anemometer sitting back there, and I'm able to calculate a CFM. So that is the volume of air that the fan can move. And let's go ahead and we'll compare them. On these graphs, I did take out the Storm T3 because I didn't really feel it was as applicable. But right here, we have the Storm, and interestingly, it is now outperforming the other fans, except at the very top end. The control is catching up right at the top end. The master fan, on the other hand, is below my control. So that's a very interesting result because the master fan did so much better in my case airflow test and in my CPU test, but it's doing rather poorly now in the CFM test. If we take a look at the other side where it's a noise versus CFM, we can see once again that the master fan is efficient at being quiet. And then we have the Storm. It's still a very good result, and the control. This is why I think it's very important to take a look at the data from several different perspectives, both a real-world test, running it through a CPU cooler, and running it through a CFM type apparatus test. I would like to get my hands on a radiator to do additional testing for a thicker, more thin, dense test so that it's much more pressure optimized. But the way you would use these graph data is if you're looking at a smaller form factor case, you want to take a look at the 6-inch mark as well as the performance data through my CPU cooler. Those give trends towards pressure optimization in fans. While if you're just looking at airspeed performance, you want to be looking at the other data points as well as the CFM data. Antec Storm120. Master Fan SF120M. All right, on to comparative data testing, where I have listed out a bunch of the other fans I've tested thus far to see how these fans, the one in this test, compare against them. First up in the graphs is the comparative data between the fans through my CPU AirCooler. So a couple notable notes about this graph. So a little while ago, I did a whole series of tests and actually published a video on it at the maximum cooling of my CPU cooler. And I used my CPU completely unlocked, letting it go to its thermal throttle limit at 91 degrees C, and just let the CPU run at whatever wattage it could draw maximum for each air speed. So I adjusted my stock fans on it down all the way to minimum RPMs of 20 PWM signal and all the way up to 100% PWM signal, and found the associated wattage for pretty much every air flow. So that's what these are. So 130 watts on my CPU AirCooler is associated to about 0.5 meters per second, while 210 watts of cooling is associated with approximately 1.5 meters per second of airflow, and I have a couple other key positions in there as well. A couple other notes about that. My CPU's maximum draw is 250 watts, and that was at something like 2.8, 2.9, maybe 3 meters per second of airflow, just as kind of a reference point. So I know I don't have any data points over here at 1.8 on this particular graph. But what does this mean for your AirCooler? Well, if you don't have the same one as me, you can't use this data directly. However, what you can do is, if let's say you have a Noctua F12 on your cooler, well, on my noise normalized results, which are based off of 40 decibels by my readings, it's not true 40 decibels, and it's 40 decibels literally with the microphone right next to the fan. Just because I'm in a noisy environment, I don't have an anechoic, I'm mispronouncing that word. Please correct me in the comments down below, but basically a quiet chamber that allow me to get noise levels extraordinarily low so that I can get more accurate readings. Also, my microphone has some inconsistencies to it. I want to get a better microphone, but I need support from viewers like you. So check out my Patreon page, check or subscribe to my channel. It really helps me grow and acquire new and better equipment. But that 40 decibel reading is based off of the Noctua A12X25 running at approximately 1,100 RPM, and I just found that that RPM to be particularly quiet on that fan, where I could just basically not hear it with my desktop sitting right next to me on the floor and my chair, well, again, right next to it. So I chose the reading that I got from my fan as my baseline measurement point. So all these fans are based off of that noise measurement. So I would consider this the maximum speed for a fan to still be quiet. So again, going back to these fans, so let's say you're running the Noctua NF-F12 and you want it to run silent. Well, you're only going to get 0.7 meters per second of airflow. Now in my cooler, that's associated with something like 145 watts of cooling. That's not a lot, but if you upgrade your fan to, let's say, the Wonder Snail, you now get 1.3 meters per second of airflow. You can instantly get a higher wattage if you have an unlocked CPU, or you could run that fan slower if you find it too noisy for you and get the same level of performance, but now it's even quieter. Or you could run the fan at that same speed, but if your CPU is locked and draws very little power, you're now running it at lower temperatures. So basically the three scenarios are: run it even quieter, run it at the same level and get a higher boost with an unlocked CPU, or have lower temperatures at a low power draw CPU. So that's the advantage of moving up the scale. So if you have the, where's the Arctic P12? Right there. So again, 0.7. So there you get that kind of performance difference. Also on this graph, I want to note my margins of error. So my anemometer, so that's the wind speed gauge, has an error of plus or minus 0.1 meters per second. So fans that are within 0.1 meters per second should be considered functionally equivalent. So for example, right here, the Arctic P12 and the Noctua NF-F12, both are rated at 0.7 meters per second. So even the SL Infinity 120, these could all be considered functionally equivalent based on the error in my anemometer. However, in actuality, I got averaged results and ran this test several times, and the Arctic P12 came out consistently higher than the NF-F12 at this noise reading. So they are in the order they're in for a reason, but if they're within that 0.1 meters per second, you could consider them to be functionally equivalent. The second note here is my microphone. I do the best that I can, but with my microphone, my error in decibel readings is plus or minus around 3.5, sometimes 4. So I do the best I can, but there is a plus or minus 4 decibel reading. So on several graphs, you may see fans that are very close in decibel readings. If they're within 4 of each other, you should consider them functionally equivalent, even though I took the average that I did, looking at it very closely, but they could be considered functionally equivalent. Back to this data, now that I've gotten all of my explanations out of the way. The master fan SF120M was spinning at 1,858 RPM. I have the ARGB version as well. The ARGB ended up spinning a little bit slower, interestingly enough, despite them having the same fan geometry and everything. And this led to a 0.1 meters per second difference in airspeed. So it's a very good result. So if you want RGB in your case, you could get the ARGB version and you're really not losing anything. Moving down to the Storms, the Storm120 regular edition was spinning at 1,300, while the Storm T3 was spinning at 1,400. They have functionally equivalent air speeds. However, the T3 was in general a little bit better, but functionally equivalent. And all of them are outperforming the Noctua A12X25, which just kind of blew my mind because this is noise normalized and not. I consider the Noctua one of the best fans, so it's just a very interesting result. All right, now we're on to 100% PWM. So you'll notice that my scale at the bottom has changed from 210, 225, 240, 250, and then, well, my CPU doesn't go higher than 250 watts. So that's where that is. If you're wondering what my CPU is, it's an 11700K. I don't think I mentioned that before. So right here at the very top, we have the insane fans that spin at 3,000 RPM. So some notable fans up here, like the T30 with 60 decibels. And then like the Noctuas are really loud, 69 and 64 decibels respectively. And the Silentwings 4 Pro 120 had a very good 53.4 decibel reading, but it's also significantly less performant, only 2.6 meters per second of airflow. As we move down the graph, we've got like the Wonder Snail, a very high performance fan for its RPM and 50 decibel reading. And then we have the Storm T3 120 spinning at 2,265 RPM at 48.4 decibels, moving 2.1 meters per second of air. The Storm 120 regular edition was spinning at 2,000 RPM, producing effectively the same noise level at 48.6 and moving 2 meters per second of air. So you do get a little bit extra performance, whether it's from that extra thickness or is it just from the RPM. It's really hard to tell with this test. But considering from the noise normalized results, they had the same positioning marker, I would say that it's probably a combination of things going on there. As for the Masterfan SF120M, it's functionally equivalent to its RGB brother, whatever you want to call them, where they have effectively the same noise level at 42, 41.6, basically within 1 decibel, so it's within my margin of error, and 1.9 meters per second of air. That is a pretty good result. It matches the stock fans on the Noctua cooler of the NF A12X25. Noise levels are better, surprisingly. So again, more interesting results going on here. And then we have other fans just on the graph. I'll let you soak it in and we'll keep things moving. Taking a look at the same data from a different perspective. So this is decibel readings along the bottom and airspeed going up the vertical. So better fans are pointed in this direction. So that's going into the top left. And what do we see? Well, the Masterfan SF120M is right here, this dark blue line, and it is a very good performing fan in this graph. It just does very well in these noise results. I did highlight the RGB version just as a comparison point. They are similar, and that is kind of the margin of error. If I got enough of these fans and tested to infinity, they'd all average out to something, probably between these two. As for the Storm, the Storm120 is this red line, and it's on the better side of the middle of the pack. So for comparison, right here I'm pointing at the Noctua A12X25, and the Storm T3 is highlighted right here. So they follow similar trends, but as RPMs or noise, I should say improved airspeed, gives better noise results for the T3's better thickness. And then we have our poor performing fans, which are like the Arctic P12. Shifting gears and moving to case airflow testing, I have selected on here a number of different fans for our viewing pleasure. It is a lot. I'm going to try to point to them as best as I can with my screen pointer. The master fan SF120M is right here. The ARGB version is right below it with fairly similar results. The Storm regular edition, as I'm going to call it, is right here. Effectively, this is a flat line. Ignore the little whoop down. The thicker version, the T3, is right here. So it actually drops underneath and then levels out over it. So it's just doing whatever it's doing. But again, just the Storms I would not recommend as case fans. The master fans look to be doing excellent in these noise normalized results as case fans. Other notable notes are the Tough Fan 12. It's doing quite well. The Wonder Snail is in there doing very well indeed. And we have this is the A12X25, which is a good result, but clearly there are better fans now. The Storm is right here. It's pretty much at the bottom. You have the Storm T3, also pretty much at the bottom. We have the master fan SF120M in this orange line. It's pretty much middle of the pack, as I would say. And the ARGB version, I believe, is exactly... No, it's not exactly underneath. It's right here, but it's still towards the top of the graph and doing fairly well. I would say it's pretty much in the middle. The non-RGB version is doing a little bit better than in the middle. And then you have like the top performers. And again, this is reliant on RPM to some extent. So we have the Silentwings 4 Pro 120, and it's just pushing a lot more air. You have the 140 millimeter version of that same fan. Then we have like the T30 before it drops off. And then this blue one is like the F12, and that's again brute force. So over here in the corner, we have the fan name, the RPM it was spinning at, and the noise level it was generating. So depending on what kind of case you have, so again, if you've got a small form factor case, you want to look at the 6-inch mark, and it's what noise level will you tolerate. If you're not going to tolerate very high noise levels, you're going to want to pay close attention to what noise these fans are generating. Taking a different look at the data, where this is at the 6-inch mark, we have noise versus airspeed. The master fan right there, the 120M, the ARGB version sitting just below it. Then we have the Storm right here, sort of at the bottom end of the better groupings of fans. And the Storm T3 sitting just over top of it. And those are doing substantially better than our like burst runners, which look to be the NFS12B and fans like that. And this is the Arctic P12 in our lower grouping of fans. So overall, the master fan looks to be a pretty good case all-rounder, while the Storm is basically just specialized. Taking a look at data from noise normalized CFM testing, comparing all the different fans. So my control is at the top of the graph, and we have the master fan SF120M spinning at that 1,800 mark, moving 60.9 cubic feet per minute of air. The master fan SF120M ARGB version is slightly less, around 1 cubic feet per minute less of air. The Storm ironically outperformed the Storm T3 in this test. despite the T3 spinning at a higher RPM. So the regular Storm was at 50 and the Storm T3 was at 47.3. And moving through, you can see the A12X25, 43.6, the T30 at 42. And let's move on to 100% PWM fan signaling. Well, the T30 tops the graph. It is spinning at nearly 3,000 RPM. It's also rip-roaring loud at 60, but it is moving 141 cubic feet per minute of air. The Noctua NF-F12 IPC, 3,000 RPM, 69 decibels, nice, and 106 cubic feet per minute of air. Silent Wings Pro 120. Here's the Storm T3 moving 84.2 versus the Storm moving 74.8. And they are outperforming, finally outperforming, the Cooler Master Fan SF120M, which produced 67 cubic feet per minute of airflow, while the RGB version produced 65.5. Taking a look at that CFM data from just a different perspective, so it's noise again on the bottom versus CFM vertical, better fans going this way, and we have the Master Fan ARGB, we have the Master Fan non-RGB, both sitting towards the top of the graph. We have the Storm that pretty much caught up to them and is just hovering right underneath them, and it just has a much better top end despite well, it just has a better top end than the Master Fans do. They just run out of steam at the top. And the regular Storm sitting right here in red, it's following the Storm T3 very closely until it reaches well, quote unquote higher noise levels and it just doesn't produce the same level of CFM airspeed basically. Now that we finished like the main graphs, let's do our open box experience and fan blade analysis and talk about why I think each of the fans got the performance that they did. Now that we finished our graphs and kind of data collection, I like to do our open box experience for these two fans and kind of go over what you're getting as well as appearance of the fans themselves and why I think we're getting the performance that we saw. So let's start with the Antec Storm 120. So they make two versions of this fan, the Storm T3 and the regular Storm. The difference with the T3 is that it's a bit thicker, and it's going to be featured in either a video before this or in an upcoming video after this one. It depends on what sort of release cycle I end up having. So this came in a pack of 3. The box looks as such. Spiral fan structure for better airflow, air concentrating design for better performance, fluid dynamic bearing, anti-vibration, yada yada yada. This came in a pack of 3, which does help with the cost because 3 packs tend to be less expensive. In the packaging here, you get some extension cables, you get some regular screws, some more regular screws, some more regular screws. Anything else cool in there? Actually, you don't get that many extension cables. Looks like you only get 2. So they're assuming that you're going to be hooking this up to a radiator. And that's about it. Mind, it can be used as a case fan. It did okay there, I believe. Or I should say, did okay as a case fan, I believe. I think it looks pretty cool. I like how the blade leads right into the front. Mind, they didn't do that to an extreme extent to cut into their logo in the middle. But it's a little bit, and it gives it a little bit of styling, at least when the fan is off. Okay, let's talk about this, the housing. So these little jingles, make the whole housing look really cool. However, it does give room for air to escape around the fan blades themselves, so it won't seal as well as it potentially could have otherwise. So that's a downside, but it does have nice rubber pads. They're pretty thick, so vibrations should not be a problem should this begin to vibrate. In terms of distance to the housing, this has pretty wide spacing there. I'd say that it sits more at an average fan than an exceptional fan. Like A++ is the Noctua NF-A12X25, while a good fan would be more like, what have I looked at recently? I guess the Wonder Snail. But the housing itself, so leading into the back struts, they got a little bit of an angle to them. That should be good at directing airflow. Very basic housing. Matter of fact, the plastic feels kind of cheap, actually, if I'm going to be completely honest. It's pretty thin, especially like right here, but that actually does mean that they could potentially have made the rotors as big as possible for this size of a fan. In terms of the blade shape, they definitely are more of a pressure optimized fan, but they have a little of a hybrid flare. So that's having a little bit of a cup shape to it, which helps accelerate the air out the back of the fan while having a overall more flat appearance. So this would be geared basically as a pressure fan for a regular fit and thickness of the fan. And the cable is braided. It looks pretty nice. The connector for the adding a second fan for daisy chaining, unfortunately, is not daisy chained. That seems like a hindsight. They just could have done it. Kind of no excuse, I guess. And in terms of noise in a pull configuration, I found this to be moderately noisy. So in what I call my medium category, a little bit annoying, but not, how should I say, ear splitting. So definitely if your CPU fans need to run at like 100% RPM, this is going to be probably annoying. But as long as you're not having to ramp up those fans, it should do just fine. And in a radiator, it should do okay, but again, these little gaps that are around the edges, that's just room for air to escape, especially if this is in a push configuration. In a pull configuration, air can still kind of seep in there and then cycle through, but kind of less likely to in that circumstance. Not sure what else to say about it. The fans themselves are just very basic. The blades are nothing special, to be honest. But it does look pretty sharp. Let's jump to the next fan. So the second fan that I looked at in this grouping was the Master Fan SF120M with patterned square damping fan frame. Whatever that means. So in the packaging, it came with all this good stuff. So it's got custom header. So this is an extension cable and I think an RPM resistor. It's got it all in the instruction. It comes with some zip ties, which is cool. The rubber style vibration mounts, as well as some regular screws. The box. It's got the various languages. Where's the performance information? If we open it up, so if the fan was sitting inside, like that, it would then talk about the patented frame design, the double ball bearing, metal shielding, premium material fan, H mode, M mode, L mode. There's a switch on it. The different features. Okay. So on the fan, where was it? Sorry, I had to pause for a second. It's pretty hard to see. So it is near the connector. So for whatever reason, they decided to use their own custom, probably proprietary connector, as we saw from the cable. It's that, which I don't really understand the reason for. If something ain't broke, don't fix it. But I guess they want to do their own thing. But this fan does have an ARGB version, so that could be potentially why they did it, so that they could have some other special type connection. But still, warranty void if removed. They can't enforce that. Mind, why take it off unless it's completely ruining your motif? But they can't enforce that in America. Oh, where was I going with this? Oh, I remember. I was talking about the speed selector. The speed selector is right there. Oh, it's pretty hard to get to. So bottom down is low, so it actually has an L, an M, and an H. All testing was done in H, high performance mode, to get the maximum out of it. In terms of the back, you can see, I think, the electromagnets and some other stuff going on the inside, as well as, I don't know if it'll show up on camera, you can see the bearing moving in the middle. So I think that these metal accents look really nice. When it arrived, one of them was actually completely off the fan, and I just sort of stuck it back on, and it's stayed on since then. But just kind of as a side note, so Cooler Master here, if you watch my video, you may want some better adhesive. The rubber pads are sufficient, and I guess let's continue talking about the frame. It's a very box-y frame, which is a good thing. That means when it's hooked up to a radiator, it creates a nice solid box around it, so that it'll focus the pressure going through it. In terms of the posts in the back, they're just rounded off in the back, and this one is simply enormous. But that is likely for room for one for the ARGB and one for the regular fan. So they just use a lot of the same features for both sides, so that's why it's so large. But it also means that that is blocking more air in that section of the fan. It's just like we're just talking about stuff on the fan, right? Anything else? Oh, I'm sorry. So now let's zoom in onto the fan blades themselves. So this is a fan that has a ring around the outside. So right there, I don't know how well it'll show up, but the whole fan is in a ring. So what does this mean? It means there's no gap, effectively. Mind, there is a gap between the ring and the outer housing. But like over time, cheaper fan blades will tend to stretch and eventually start ticking against the side. That is unlikely to happen with a ring. But mind, if the rotor is not centered properly, you could get ticking still, but different topic and less likely to happen. The downside of having that ring is it makes the fan heavier. So if there's anything wrong with it, any like weight offset or anything like that, it's going to transmit more vibration because it weighs more. So there are advantages and disadvantages. It means that it can't achieve an RPM without a stronger motor. And stronger motors are more expensive, and you get into this cycle. The blade design themselves looks, I like to bring out my trusty NFA12X25 as a comparison. They look very similar in terms of blade shape and design. However, I think these look a little bit wider and definitely have a steeper blade angle to them. They do feature this cool geometric pattern on it. I personally, looking at it, don't think it does anything aerodynamically. I just don't see that shape, and it does not ring any bells for me for anything to do with airplanes or moving air. I think that's just purely for aesthetic is what Cooler Master did. Mine, it looks really cool. And the back, it's very shiny, but it has a little bit of a cup shape to it. And definitely because of this outer ring, the air gets focused through the back. So instead of needing some feature on the blade themselves or the frame, so this is where the gap is important. You're using the frame to help focus the air through the back. Literally, because effectively for the fan blades themselves, the frame is the blade, the air is automatically focused through the back because pretty much no air is going to travel through that gap. So the likelihood of air reversing the wrong direction is very low. So that means that this fan is very good in pressure applications as well as in airflow applications, making it a great all-rounder. And because of its, oh, where'd it go? There it is. The speed selector, you can choose what kind of maximum RPM you want. So you can select the lower, setting it in low RPM mode or low power mode means that your minimum RPM is lower, as opposed to the high speed mode where your minimum RPM is higher. So you can choose where you want it to place based on where you're using this in your case. And because it physically looks, I'm going to say beautiful, you probably want to show this fan off. If you're just sticking it somewhere and it's hiding in the back, sure, it'll perform great, but I guess at that point it doesn't matter much. So this is a showcase, a showcase fan. Visually, just something that looks really cool. Personally, I don't like this spinning logo, but hey, whatever. It's got a metal housing behind that. I don't know what else to say. I would say the only thing about this fan that I really don't like is the custom connector, in that it gets kind of bulky. It doesn't, I guess it can squeeze in there, but it just seems like a weak point. Like if you ended up folding it the wrong way, is that going to break? So it's just limiting itself kind of for the wrong reasons. And I hope they're not spending extra money on that and then passing it along to us. Anyways, let's move on to the next section. Oh, did I talk about how noisy it was? Sorry, before we jump to that section, so in a pull configuration, I found this fan to have a slightly high-pitched noise. A little bit annoying. Again, I don't remember if I mentioned it. A little bit annoying, but not terrible. Definitely would be tolerable, but that's up to you, the user, whether you can deal with it or not. But found it to be tolerable. And that comes to do with how close, like this comes right up to the edge. So basically just got this spacing for the rubber grommets as that. They even like filed off, or when it was molded, it's got a flat edge right there. Anyways, now let's go to the next section. All right, now that we have finished going over the fans, their appearance, their features, and all this, and all the data, we're on to price to performance ratios. So first up is the price of the fans. The Storm was purchased in a triple pack, making each fan $12, the same price as the T3, as a matter of fact. The Master Fan SF120M, when I purchased it, was $35. The ARGB version was $38, so there's not a huge price difference between those two fans for their very similar performance values. So my value proposition ignores things like RGB, and it purely looks at the airspeed versus how much money it costs. But if you're looking for RGB, you at least know that it's got performance at a similar price. So I've highlighted the fans that are applicable to this, and then I've added in the two other ones that are the equivalent fans, just like the T3 thicker one or RGB version. So the Storm is an excellent value in my case airflow test. And that comes down to its lower price. But one thing to note is that its mean time between failure, so its lifespan, is shorter. So when you buy a more expensive fan, you pretty much can guarantee that it's going to last longer, have a longer life. So depending on what's important to you and how much money you have, you want to weigh in different things. So if you only care about raw performance and getting the very best that you can get, look at my performance data, completely ignore these graphs, jump to the next section. If you're on an extraordinarily tight budget and you're looking for the best bang for the buck, you want to focus in on these data graphs and select your fan from here. And if you're an average user, more like myself, where you want to get a good value, but you want good performance. So very good performance at kind of the best value ratio. That's when you kind of compare the two and pick out the best one that suits what you think your needs are. All of that said, so the Storms are ranked very highly at the 6-inch mark. The Master fans are ranked above average, but still kind of in the middle-ish. When we're taking a look at 100% PWM fan signaling, the Storm T3 does significantly better than the regular Storm, but they're still shifted towards the top, but they are not the best. That belongs to the TLG12, and actually the F12, and the P12. So noise normalized, keeping the fans quiet, 100% PWM, don't care about noise at all. Let's move on. So the next one is the same sort of thing at the 9-inch mark. So how do these fans compare? Well, the Masterfan SF120M finally kind of catches up to the Storm. Previously, the Storm just completely outperformed the Masterfan, but because the Storm just dissipates air in all directions so badly, the Masterfan catches up. Interestingly, the Storm T3 hangs on to its position fairly well here. But again, I really wouldn't recommend that as a case fan. The Master fan is hanging on pretty well, and the ARGB version, they're above middle of the road, I would say. Moving on to 100% fan speed, and the Storms kind of claw their way back up to be slightly above average, while the Master fan has kind of dropped back in position. But it's still not a bad result, it's just more middle of the road. Taking a look at CFM per performance, the Storm, it's a chart topper. It is a truly excellent result in this noise normalized test. And the Masterfan SF120M is still slightly above average, with the ARG version just a little bit behind it. So it's not a bad result. It is a good fan for its price. Taking a look at once we're running at 100% PWM fan signaling, the Storms continue to do well. Though they lost their chart topper category, they are still ranked, second and third? So that is a good position for those fans to be in. And that comes down to their triple pack price, where the Storm is like $12. The Masterfan has kind of become very middle of the road. It's not a bad position to be in. It's just not a top value fan. And last, but certainly not least, the value proposition running it through my CPU AirCooler. Well, the Storm is once again a chart topper in this category. It is a truly excellent result. The TLG12 was my previous best, and it just kind of blows them out of the water. So if you need a cheap fan to strap to your CPU cooler or radiator, they might be the top picks. The Masterfan does well. It's above average, but it's significantly lower than the other fans. Once we're taking a look at 100% PWM fan signaling, we can see like the Noctua A12X25 actually is kind of doing better than the Masterfan. And the two Storms have dropped back in position compared to the TLG12, the C12, it's about equivalent. So they are still towards the top, but not quite at that top value proposition. But they're good results. So would I recommend these fans? Well, their lifespan leaves a lot of questions for me. as to how long they'll actually last. So that's the only reason I wouldn't say, yes, go out and buy it. But if you're looking for a good value and you need to fill your case with some fans, I don't think you could go wrong. Anyways, let's jump to my conclusion section.
Well, that's my video for today. Thank you very much for watching. Please subscribe for more content. I've got lots of fan videos, both upcoming and that I've already done. And please check out my Patreon page. But anyways, thank you very much. Have a great day, and I'll see you next time on Computer Tech and More.
And now that we've basically just finished the review, this is just so I have published my raw data. This is the Cooler Master Fan SF120M, and here's the Antec Storm120. This data, you are welcome to use it for your own personal uses, like generating your own graphs, whatever, or if you want to make a publication. However, I do request that if you make a publication using my data, you must give me reference, because it takes me like 40 minutes to an hour to generate data for each fan. Graphs, even just updating all of them takes like an hour. Making the PowerPoints, or the PowerPoint used to make the video, was a couple hours. So it's just a lot of work for me to make these videos essentially by hand right now. So please reference me as the data generator and reference my video. But thank you very much for watching. Have a good one.